Hey guys, my name is Amir, and if you've ever written code before, you know that fixing security issues has always been a struggle. And in this video, I'm going to show you how platforms like ChatGPT can address this need in a much more simple and cost-effective way. Instead of spending hours learning how to find and fix vulnerabilities or using complex scanners which are always prone to false positives, I'll show you how ChatGPT can help you with detection and remediation of security vulnerabilities. Now, before we begin, give this video a like and subscribe because that helps me create future software security content. Now, for this video, I'll be showing vulnerable code with the following vulnerabilities. These are the type of vulnerabilities that are commonly introduced by developers, and I wanted to test how good or bad ChatGPT is with detection and remediation of these type of vulnerabilities. First, let's start with a basic example of a SQL injection vulnerability. This is a post request where the add user endpoint is adding usernames in the user table. The attacker will use this query and supply it as a username to extract all the information from the users table as unsanitized username value is being injected directly into a SQL query. Now we will copy this piece of code to ChatGPT and ask it to find issues within this code. So here, ChatGPT was easily able to identify the vulnerable portion of this code, which is the unsanitized username value going directly into the SQL query, which can cause an injection attack. ChatGPT then provides an example here showing the fix that it made to the username value by adding parameterized queries, which eliminates the risk of SQL injection. What I would have also liked to see is ChatGPT recommending input validation and sanitization, which is also another effective defense mechanism against injection-based attacks. Nevertheless, it did fix the issue, and that's what's important here. At number 2, we will look at a code example which contains cross-site scripting vulnerability. Cross-site scripting occurs when an attacker uses your vulnerable web page to deliver malicious JavaScript. Here's an example of an API endpoint, which is a login route that receives a username and password in the request body, and then the code checks if the user doesn't exist in the database. If the user doesn't exist, the function will throw an error message to the front end. This error will reflect on the front end without any validation. The attacker can use this script as a username, and when the error is shown, this script will replace the URL of the current site and redirect the user to a malicious site, which will show them phishing content or just straight up download malware on their machine. So to find out about the issue with this code, we will ask ChatGPT and see what it has to say. So right off the bat, ChatGPT was able to detect the problem within this code, and it's reporting a cross-site scripting vulnerability. And the reason why this is an issue is because the code is directly injecting user-supplied input into the HTML response without proper sanitization or encoding. So what ChatGPT recommends is to use a library or a function to escape the HTML or sanitize the error message to prevent cross-site scripting from happening. So in the final code example provided by ChatGPT, it wrote all the fixes that it recommends. And as you can see, it's not outputting any username whatsoever, which also helps because now we're not directly outputting user control data on the front end. However, we can also choose to do encoding or doing input validation as well. Moreover, it did a username check first, followed by a password check, which prevents time-based attacks that it pointed out earlier. Overall, a pretty good detection by ChatGPT, and I also like how it told me about issues that I thought weren't existing, such as timing-based vulnerability. At number 3, we have a calculate endpoint, which is a post request, and it calculates the output of two numbers based on the operation supplied by the user. The code then performs the operation in the eval function and returns the output. The eval function being used here is vulnerable to remote code execution because it receives unsanitized user input, which can be used to execute malicious commands. An attacker can pass the following command as an input, and this will delete all the files in the root directory of a Unix-based server. Now let's see what ChatGPT has to say about this code. And as you can see, ChatGPT has identified the most crucial problem with this code, which is the use of the eval function and the way it's being used. It then shows a different way of doing calculations without the use of the eval function. ChatGPT even went further and implemented validation on the numbers as well. The function now enforces numeric checks before calculation is processed to ensure that only numbers are permitted in this function, as this helps prevent any malicious scripts from executing. So overall, this was a solid detection by ChatGPT. At number 4, we have a piece of code which is vulnerable to privilege escalation. This code is a update user role post request, and it receives a user ID and new role values in the request body. It checks if the user exists in the database and then makes the role change. Now let's put this code in ChatGPT and see what it has to say. So right off the bat, ChatGPT is complaining about the lack of input validation on the user ID and new role parameters, which is correct. It then wants us to do a better job with error handling. It then points to a lack of authorization, and this is a main issue here where pretty much anyone can use this API endpoint and increase their privileges to an admin, for example. And then it talks about using Mongoose promises for better error handling. So I think it just assumes that we're using Mongoose for our database, so that's why it's recommending it. Once we take a look at the updated code provided by ChatGPT, we see that ChatGPT has made certain recommendations. The first one is to add a middleware inside the API endpoint so that it can intercept the requests to validate the user ID and new role parameters. In addition to that, we see a comment to check if the authorized user is making the change, not anybody else. And that makes sense because we don't want anybody to change their role. We want a specific person, such as an admin, to make changes to someone's authorization roles. So ChatGPT does a pretty good job here at identifying the authorization issues. And if we do implement these changes, we should be able to eliminate any type of privilege escalation that can happen here. Up next, at number 5, we have a code example that results in a denial of service vulnerability. If an attacker injects large amount of data in the user input, which is just being used here blindly with no length restrictions whatsoever, the loop will go on forever and will prevent other operations from happening. So once we give this code to ChatGPT, it was able to provide some recommendations, and right off the bat, ChatGPT was able to detect a lack of input validation, which makes perfect sense as there are no checks for malicious inputs. So here ChatGPT is adding validation function from importing express validator, which validates the request to prevent malicious inputs. Next, ChatGPT is complaining about the potential of an infinite loop, which is perfectly correct because if there are no length restrictions, an attacker can inject gigabytes worth of data in the user input, and the for loop will just keep looping for hours and hours using lots of compute, which will be very costly, or it might just end up taking down the server altogether. So here ChatGPT has set a maximum length of 1,000 characters and enforces it before the for loop is initiated. So all in all, a pretty good response from ChatGPT as before, as it was able to identify the core issues with this piece of code successfully and provide solid recommendations. At number 6, we have a code that is a login post request, and it uses username and password from the request body to check if an admin is trying to log in. Now, obviously, just by looking at this code, you can clearly tell that this code is vulnerable to Authentication Bypass, and we will be testing ChatGPT against this to see if it can find and fix the issues for us. So here ChatGPT recommends not to use hard-coded credentials, which obviously is one of the biggest issues with this piece of code, as we have just statically typed username as admin and password as admin123. Moreover, ChatGPT recommends that you should be storing credentials securely in the database by using secure hashing practices as opposed to statically typing them. Moreover, it talks about adding rate limiting to prevent brute force attacks because attackers, in order to find the password for an admin, can keep trying random passwords until they guess the admin password. It then talks about the lack of session management and recommends using express sessions. It also talks about the lack of input validation, which is also true because we're not validating any type of input. We just blindly take the username and the password and start checking if it's an admin user or not. And lastly, it recommends implementing proper error handling and using HTTPS. Looking at the updated code that ChatGPT provides here shows it imports a couple of libraries, and then what it does is provides a hash of a password, and basically this will be pulled from the database. As the comment says, this is just an example. Next, ChatGPT is using a library called bcrypt to compare passwords that it received with a hash password in the database, as opposed to doing clear text password comparison, which is a bad practice. And then if everything checks out, then it sets a session to true, meaning that our admin is now logged in. Now overall, ChatGPT has good recommendations. However, there's one thing that I wish that it would have talked about, and that is password requirements. Now here in this example, we're using admin123 as a password, which is a bad password in every way as it's easily predictable because it's not random. It doesn't use any uppercase alphabets or special characters, and the length is extremely low. The ideal length of passwords is 16 at the time of recording this video, and all these requirements increase the complexity of passwords, so brute forcing becomes almost impossible. Now having said that, the one takeaway that I want you to understand from this video is that ChatGPT generally does a pretty good job with its security recommendations. However, these recommendations are not perfect, so get into the habit of always doing your own research outside of what ChatGPT or any other LLM recommends. At number 7, we have a code here, which is a user details API endpoint. And this takes a user ID as an input from a request query parameter. The code sends the user details to the front end based on the user ID. Now, the issue with this part of the API is that it's revealing sensitive information about a user, as anyone can supply a user ID inside a request query parameter and use this API to get information about anyone. Now we put this into ChatGPT and let's analyze its response. So ChatGPT is recommending a couple things here. The first one is input validation, which is true because we're not doing any validation whatsoever. It then talks about error handling, which is also correct. And it then checks for rate limiting, which also makes sense because we don't have any type of rate limiting on this API. So anybody can brute force this and guess random user IDs and get details about them. The recommendations provided by ChatGPT make sense, and all of them do apply to this code. However, the issue that wasn't recognized here is the use of query parameters for a sensitive feature. What I would like to see is ChatGPT recommending against the use of query parameters for sensitive features, such as supplying a user ID in a query parameter, as it is not the best way to supply a user ID. It should be in a post body so that no one can see it, even if they are sniffing your network traffic. Moreover, I would have liked to see further validation through access controls and some type of authentication on this API so the malicious users can't access it. So as mentioned earlier, ChatGPT is good with its recommendations, but it misses out on a few items every now and then. At number 8, we have vulnerable libraries, and in this example, we have an API endpoint, and it's using Axios, which is a third-party library for making API calls. And it's doing a login by supplying a username and a password to another API endpoint. Now the issue here is the use of a vulnerable version of the library, which is 0.11.1. Now once we put this into ChatGPT, we see that the first thing that it picked up was the older version of Axios being consumed, and this is excellent because this is exactly what we want to recommend against. However, in this statement, ChatGPT is recommending to use the latest version. It doesn't say if this version has vulnerabilities or not. So just something to keep in mind, that ChatGPT is not perfect and doesn't know everything. Moreover, it changed my code a little bit by changing a conditional statement and added better error handling, but overall, it did a pretty good job by removing an older version of Axios, which was vulnerable, and this is exactly what should be happening. At number 9, we have a few lines of code that performs a post request to a PayPal API for a purchase order of $100, and it does that by using a client ID and a client secret that is hard-coded inside the codebase. Now, just by looking at this, the thing that stands out is the clear text client ID and the client secret being put inside the codebase. Just always remember that it is always a bad idea to put any type of secret or credentials inside your codebase, because in case of a repository compromise, the attacker can steal these secrets and gain access to other parts of your app as well. And in this instance, if an attacker is able to get a hold of this app, they will also get a hold of the owner's PayPal API as well. When we ask ChatGPT about this code, it recommends a few things. The first one is the improper storage of secrets. It recommends storing secrets in a codebase is not a good choice. It also has a couple more recommendations, such as the use of environment variables for secret storage, input validation, use of HTTPS, and I think some code improvements as well, such as using async and await. The code here shows all the changes that ChatGPT has recommended. Now, the thing that you should know is that you can use environment variables to store secrets as recommended by ChatGPT, but even environment variables are not the best option for secret storage, because at the end of the day, environment variables will be stored on a machine, and if somebody gets a hold of that machine, they can get a hold of the environment variables and all the secrets. The best option for storage of secrets is to use a password or a secret vault, such as HashiCorp Vault, AWS Secret Manager, or Azure Key Vault, because they have inbuilt encryption, authentication, and access control procedures, which makes your secret storage even more secure. Lastly, at number 10, we have this piece of code which contains two functions. One is hashing passwords with MD5, and the other is encrypting usernames. Both of these functions are using old insecure algorithms, and ChatGPT also detects them with no issue whatsoever. ChatGPT recommends using bcrypt for hashing, and also went ahead and added salt to further secure users' passwords. It replaced the DES encryption algorithm with AES 256, which is secure, and it also removed the hard-coded encryption key, which is obviously a bad idea, and replaced it with an encryption key that it received from the function itself. And it does say to securely store the encryption key elsewhere. So overall, very solid recommendations by ChatGPT. ChatGPT is a great resource for finding security issues as it provides great recommendations. However, it has its shortcomings too. So to help you decide if you should use it for your project, here are some of the pros and cons of using ChatGPT for vulnerability detection. ChatGPT is not language specific. It understands almost all modern programming languages, unlike traditional security scanners which are language specific. The other great aspect of ChatGPT is that it fixes the code for you, which usually doesn't exist with many security tools which only provide recommendations. ChatGPT goes beyond the traditional security approach and will add improvements to your code to make it more optimized. Traditional security scanners need to be configured to your environment to scan, which can be time consuming. With ChatGPT, all you need to do is copy and paste your code in as a prompt. And lastly, ChatGPT is a free tier, and that's what I used in this video, so you don't need to worry about paying licensing costs. Now let's talk about the cons with ChatGPT. The first one is that ChatGPT cannot scan the whole codebase. For that, you will need to try out traditional static application security testing tools, which do scan the entire codebase. ChatGPT does not do a good job with scanning libraries. With my testing, ChatGPT struggles with finding vulnerable libraries and providing references to support its claims. So for libraries, I would recommend sticking to traditional security scanners. The other issue here is that the knowledge base of large language models relies on when the model was last updated. At the time of this recording, ChatGPT was last updated in April of 2023, which was 9 months ago. This means that it won't know about new vulnerabilities that might have come up since its last update. And lastly, ChatGPT, just like many other scanner tools, is prone to false positives and false negatives. So my final verdict is that if you need a quick scan of a piece of code or a small project, try ChatGPT as it's fast and doesn't need a setup like many other scanners. However, in a large enterprise environment where you might have millions of lines of code, you have to stick to traditional static application security testing tools as they're designed to be used in that area. I hope this video was helpful. If you have any questions, drop them down in the comments and I'll see you in the next video. Take care.